The next sum says one end of a copper rod of uniform cross section and of length 1.5 meter is kept in contact with ice, which is assumed to be 0 degrees Celsius, and other end with water at 100 degrees Celsius. At what point along its length should a temperature of 200 degrees Celsius be maintained so that in steady state the mass of ice melted be equal to that of the steam produced in the same interval of time? Assume that the whole system is insulated from the surroundings. Latent heat of fusion of ice is 80 calorie per gram and latent heat of vaporization is 540 calorie per gram. Now one thing you need to understand over here is, this is say the copper rod whose total length is 1.5 meter. Say this end is at 100 degrees Celsius water and this end have 0 degrees Celsius ice. So there is a point which is say maintained at 200 degrees Celsius, because of which the heat flow from 200 to 100 in this direction as Q by T 1, and the heat flow in this direction also as say Q by T 2. But they want the distance of this 200 degrees Celsius from one of the two ends such that the amount of ice melting at this end is equal to amount of steam produced at this end. So here if we assume the length to be delta x1, I can say the delta x2 over here is this, and that is equal to 1.5 minus delta x1. Now they want the mass of ice melting to be equal to the mass of steam being produced, correct? So first thing we can say is Q by T 1 is going to be K A delta theta 1 by delta x1. So over here Q, which is heat transferred, is being used to convert the water into steam. So this is going to be mass of steam produced or mass of water which is converted into steam into latent heat of vaporization upon the time, which is equal to K A. Delta theta 1 is 200 minus 100, which is 100 degrees Celsius, upon delta x1 as an assumed length as delta x1 itself. Now similarly, if I apply Q by T 2, I get it as K A delta theta 2 by delta x2. Now here the heat which is supplied is used to melt the ice. So over here we are going to have mass up into latent heat of fusion upon the time T is equal to K A. The change in temperature is 200 minus 0, which is 200, and delta x2 is 1.5 minus delta x1. Now if you understand over here, the mass and time, thermal conductivity and area of cross section in both the cases are going to be same. So if I rearrange this equations and write it as m upon K A T, it's going to be 100 upon delta x1 into LV, and over here I'm going to get it as m upon K A T is equal to 200 upon 1.5 minus delta x1 into LF. So if we compare this two equations, the left hand sides are equal, so I can equate right hand sides. And so this is what we get by equating them. Now if I cancel these two zeros and cross multiply, we get 1.5 minus delta x1 into latent heat of fusion is equal to 2 times delta x1 into latent heat of vaporization. Now substituting the value of latent heats of fusion is 80 and of vaporization is 540. Definitely cancelling them is zeros is good option. The 2 gets cancelled over here and make this as 4. Now if I open the brackets over here, we get this as 1.5 into 4 is 6 minus 4 times delta x1 is equal to 54 times delta x1. This goes over here, becomes the addition, and we get delta x1 58 times is equal to 6, which means delta x1 is 6 upon 58. Now this is what we got as delta x1. If you remember, delta x2 is 1.5 minus delta x1, which means it is 1.5 minus 6 upon 58. Now if I simplify this 1.5, I can rewrite this as 3 by 2, which means I need to multiply 58 with 3, which will be 174 minus 12 upon 58 into 2, which is 116. So if we calculate this part, we get delta x2 as 174 minus 12 as 162 upon 116. Now we need to simplify this with the decimal value because the option contains 1.296, 1.196, 1.396 and 1.496. So if I reduce this down, I get this as 2 8s, 2 1s, 2 5s, 2 8s. Now further reduction is required. So I can say 58 1s is 58. So 81 minus 58 is going to give me 3 and 23. If I put decimal, I get this as 230. Now I know 58 into 4, if I apply, it will be 32, 232. So it is just less than 1.4, which means it has to be 1.396, and that has to be the final answer.